And we're recording. Awesome. So this should be getting recorded right now if everything goes according to plan, and then I will post this video on today's calendar. All right. So guys, we're going to go through 3 examples of solving equations. The focus is going to be how to use technology to solve an equation. That's going to be the focus. But before we use the technology piece, I wanted you to see certain equations like this one that we should certainly know how to solve by hand. And so we're actually going to solve this together by hand first. And even if you watch the other video with the graphing calculator, I do the same thing. I went through how to do this by hand first. That's always a skill you guys should have. You should always know how to do some solving equations by hand. So I picked one that was kind of at the Algebra 2 level for us to go through really quick by hand. So if you're in on this one with me, then follow along. So one of the harder scenarios that I've seen students run into where they get stuck and they're kind of not sure where to go from here are anything involving fractions. That seems to be a tough case for people, and they kind of forget, well, what can I do from here? Anyone know? Anyone have a suggestion as to what I could do first on this? I could add 2 to the other side.
Multiply the x on the right to the left.
Yeah, so whether you added 2 or not, the main thing is get rid of the fraction, right? So we get rid of the fraction by multiplying everything by this denominator. So I'm simply going to multiply x over to the other side. So it's going to become, and it will distribute, so it's going to become x squared minus 2x equals 1. So generally speaking, when you're looking at an equation with a fraction in it, the goal is to get rid of the fraction, and the way you always do that is by multiplying by your denominator. So that's kind of a key step I wanted you guys to see. Once you hit this stage, now we're obviously looking at a quadratic. We all know I want my quadratics to equal 0 before I try to solve it. So I'm going to subtract that 1 over to this side, set it equal to 0. And now you can go back to any of your quadratic methods for solving. You can try to factor it if it's factorable. This one is not. There is a process called completing the square that you guys have all learned, but typically never choose to use. And then there's the quadratic formula. You can actually solve this by graphing, but this would be a hard one to solve by graphing because the answers are like irrational numbers. So we're going to go back to the good old quadratic formula. This is one formula that I think everyone should know how to use. So here's that formula for those that don't remember, but I'm guessing a lot of you guys remember this one. Looks like this. Guys, there's a purpose for me doing this with you, so stay with me. This is more than just review. I want to show you something, but you're going to see it mostly at the end of this problem. Well, you guys know the drill from here. We've done this. You've done this plenty of times before. So this is your A value. It's a 1 since there's no other number written there. Our B value is -2, and our C value is -1. So take a minute with me. Let's plug those into our quadratic formula. Because the one thing I would encourage you to just do in your head is this one right here, b squared. Don't write out -2 squared, right? People make mistakes on that. It's easier just to square it in your head. That's the one thing I would say, just simplify in your head as you lay this out. Guys, here's the first thing I would look for when I go to simplify a quadratic is how many negatives are there? Because as I clean up these numbers, this is either going to be 4 plus 4 or 4 minus 4, right? And in this case, I can see that there are 2 negatives, which means I should be adding right now. So I'm going to, inside my radical, I have 4 plus 4. And that should put you right here. So guys, here's one of the main reasons I like to show you this problem by hand. My answer is a radical, right? It's an irrational number. It's not something that's going to come out to be a nice, pretty number. If you try to put this into a calculator, you're only going to get decimals. Even if you're doing this on Desmos, you're going to get decimals. Well, what if the situation calls for an exact answer or an answer in radical form? This is something I need to know how to do by hand. There's a couple important skills in here that you guys should all have moving forward, no matter what math you take after this. One of those is the use of formulas. The next is simplifying a radical. So this is kind of the next thing I wanted to remind you of, is how do we simplify something like the square root of 8? When you go to simplify the square root of 8, let me just do it kind of right here off to the side. I'll remind you, depending on what teacher you've had in the past, they would have taught you 2 different ways to do this. So I'm going to show you both really quick. I can look at this as the product of a perfect square and a non-perfect square. When I look at 8, I know that 8 is 4 times 2, right? And the reason I look at it as 4 times 2 is because 4 is a perfect square. So if I want to simplify this, I'm going to look at this and say, well, what's the square root of 4? The square root of 4 is 2. But this guy that's not a perfect square has to stay under that radical. He can't be simplified. So I'm taking the square root of 4 to just be 2, and then my non-perfect square is going to stay as a radical because he's not a perfect square. So that's one way. So that's one way to simplify it, is to treat it as, look at the perfect square and the non-perfect square and simplify the perfect square portion of it. The other way you would have seen this would be to use a little factor tree and break down 8 into prime factors. And so we would say, okay, what are 2 numbers that make 8? 4 times 2, and then 4 can break down as 2 times 2. And so we kind of look at this with like a factor tree. And the idea is, when I think of a perfect square, I'm always looking for something times itself. Thanks, Antonio, you get an A. Right, a perfect square is something times itself. So when I look at the prime factors of 8, which are 2 times 2 times 2, I'm looking for, well, where do I have a number times itself? Right, obviously that would be this guy. And so whenever I see I have a number times itself, that's what gets to leave the radical, and whatever did not have a partner has to stay under that radical. And so you would have learned one or both of those methods at some point for simplifying radicals, but that's an important skill. So let me rewrite this guy now with my simplified radical. So we simplified the square root of 8 to become 2 root 2. And now here's the one last thing that I wanted you guys to see. What can I or can I not do at this point? Because there's a lot of confusion on simplifying fractions like this with radicals involved. So let me give you a couple quick do's and don'ts on this. First of all, I can never mix a radical with a non-radical, right? These numbers could never reduce because one's a square root and one's not a square root. So don't ever try to simplify those numbers. When I look at this, whenever you guys first learn quadratic formula, one of the things that your teacher would have probably totally hammered you on is make sure that you draw this fraction bar under everything, not just the radical, but everything. right? That's important because when I get to this piece right here, I need to recognize that this 2 belongs to everything on top, right? So if I'm going to reduce, you see there's 3 terms here. I have this number, I got this number, and I got this number. I can only reduce this if I can reduce all 3 of those values by the same number. So, and in this case, of course, we can, right? I can divide 2 into all 3 of those. So if I divided all of those by 2, then this would be the simplest way to write that answer. So 2 goes into here once, which I need to show. 2 goes into here once, but 1 radical 2 is the same thing as radical 2. I don't have to write this as a 1. You certainly could. You could put a 1 right here, and there's nothing wrong with that. You just don't need it. It's like putting a 1 on bottom. When I divide this by 2, that gives me a 1 as my denominator. So if you put that whole thing over 1, it's not wrong, just not necessary. This would just be the simplest way to write it. So I want to remind you guys just some of your solving by hand stuff. I think it's important that you know how to do those things. So let me now switch over to the technology side of this here. Okay, so how can we solve an equation with technology? Because there is going to be certain cases like this one and like this one where you would never, you probably couldn't even solve this by hand if you wanted to, because it's too complex. So let's take this guy first of all and solve it in Desmos. What we're going to do is we're going to create 2 graphs. I'm going to create one graph for x minus 2, and then I'm going to create a different graph for 1 over x. And what we're looking for is, where do those 2 graphs equal each other? Where do they intersect? That's what we're looking for. So do this with me. We're gonna open up Desmos, and we're gonna make one graph for just x minus 2. So we're gonna go into, oh, I thought I had Desmos up. So go into Desmos.com, click on Graphing Calculator. Remember, whenever you want it to graph something, you have to start with f of x equals, and then type in your function. So in this case, we're doing x minus 2. And there's that graph, nice linear graph. That would have been an easy one to do by hand. But let's do the other side of this. So open up a second window here, just click or hit enter, and you'll open up that second window. And we're going to do the other side of the equation, which was 1 over x. So again, I'm going to say f of x equals 1 over x. You probably don't need the calculator feature for this, but that's what it looks like. So there's our 2 equations. So you guys can see there's 2 points of intersection. And that's no surprise. When we solve this by hand, we got 2 answers. We got 1 plus the square root of 2, and we got 1 minus the square root of 2. So we have 2 answers. So when I look at these 2 graphs, I should see 2 points of intersection, right? It's those points of intersection that represent the 2 solutions. When you do this in Desmos, it's kind of nice. You don't have to like click on anything. What this does for you is, if you can see the little gray circle here, Desmos automatically identifies important points, like points of intersection. So if I just hover over that gray circle, you can see in parentheses, it gives me that point of intersection. And if I hover over this one, it gives me that point of intersection. Okay, hear me on this, because this is like super key for the lesson today. When I look at this point of intersection, you'll notice it comes up as an ordered pair, an x and a y. What of that matters to us? Look at the equation. Do you see a y value anywhere in there? You don't. I don't want the y values. All I am solving for is x, and that's it. So we are not solving a system of equations that has an x and a y in it. I'm just solving one equation, and it just has x. That's it. So do not write down the entire ordered pair. You would lose points for that. because the y coordinate of that doesn't matter. The y coordinate is not part of this answer. Only the x is. So first thing I would write down is the 2.414. That was the first solution. And then this one, if I hover over this gray circle, I see that x coordinate, which is negative 0.414. Only the x coordinate matters. That's it. That's all you got to do. We can now use this to solve any equation we want to solve. You graph the left side of the equation as one graph, you graph the right side of the equation as another graph, look at where they intersect, and you got your answers. So let's try it with the next one. So guys, this is one where you wouldn't be able to solve this even if you wanted to, because the x's on this, one of them represents a base, the other one represents an exponent. Good luck solving that. So we would need technology for this. So again, I'm going to go back into Desmos. I'm going to make 5x my first graph, and then 3 to the x power my second graph. So I'm just going to backspace here so I don't have to retype my f of x. So 5x is the first graph. And then I'm going to do 3 to the x power. Remember down in this calculator down here is where you can find math functions. So if you need like an exponent or a radical or pi, things like that are all in this calculator. So I'm going to do 3 to the x power. So as I look for my point of intersection, here's something to be careful of. Make sure you look at the whole graph because there's more than one. There's more than one, so make sure that you see it all. You can zoom out, you can zoom in, you can slide it around if you just click and drag, but make sure you see them both. If my window is too small, like if this is all I saw, I might look at this and think, oh, there's only one point of intersection. Well, there's more, so make sure you see it all. So again, you can zoom out, you can zoom in, clearly 2 points of intersection. Get rid of that. So again, I should see these little gray circles come up. So I can see a little gray circle right there. So if I just hover over it, I can see the x coordinate is 2.17. So that would be my first solution. What's up, Derek?
So is that the first intersection you write down?
It doesn't matter.
Or it doesn't?
It doesn't, yeah. Yep. As long as you identify all the solutions, the order is whatever. So 2.17, the other one, I can see this gray circle right there, 0.269. I like how they use 3 sig figs because you guys are often asked in this class to write your answer to 3 sig figs. So it's kind of nice that they're going that deep so that we can get it all.
So you should only put X, not Y.
Correct. Only put the X. If you include the Y, it is a math sin and the math gods will be angry at you. They throw down lightning bolts in the shape of math symbols. All right, one more. I wanted to give you one more that was a little extreme, something that would obviously not be doable by hand because I'm dealing with an exponential function. I'm dealing with a trig function. A lot going on here. So, but let's just take the same approach. Graph 2 to the 1/2 x as your first one. So 2 raised to the 1/2 x. It's going to be our first one. And then I got this guy. So 2 plus sine pi x. 2 plus sine pi x. Sine pi x. Guys, let me mention something real quick. on this one. We don't get a lot into degrees versus radians in this class when it comes to trig functions. But just as an FYI, if you're doing a trig function and it is in terms of pi, that means you are in radians, not degrees. So if you ever need to change that in Desmos, it's right here in this little wrench. These are your graph settings. So if you click on the wrench, look at the bottom. You get the option of degrees versus radians. Okay, and so for this one, I want to be in radians because it is in terms of pi. Okay, if that was in terms of degrees, like instead of pi, if they put 180x, so it's in degrees, then I can just click on this and it'll graph in degrees. But I want this in terms of radians right now. But again, guys, real simple, right? As I look at my screen, I can see 3 points of intersection. Right, 3 clear points of intersection. So all I have to do is hover over the gray circles and I can see my x coordinates. So I got the 1.167 would be the smallest solution. Hover over that one, it's a nice, easy integer, just 2. And then here's your third one. So that's it. So now you know how to solve any equation under the sun using technology. So guys, let me, I'm going to stop the recording here. So for anyone who wants to look back at this.